relational databases are now available in Azure. These are the databases that most people are likely to be familiar with as well. As a result, we now have access to Azure SQL. If you will, this is SQL Server in the cloud. However, there are a wide range of options to choose from across the entire spectrum of possibilities. A managed instance makes it simple to switch from on-premises SQL Server to the cloud. Using elastic pools or software as a service allows you to share resources across a diverse set of databases, even if their usage patterns are very different. So, it's very well suited to a variety of cloud environments. Other relational databases, such as MySQL, MariaDB, and PostgreSQL, are also available. The self-host or service-based model is available for all of these options. Virtual machines and containers can be used to run any of these, but they all have a service-based model that allows you to provision an instance of this so that you can focus on your application development or data storage. As a final point, all of these are built for the cloud, which means they are scalable, available, and global. It's not just relational data that you can use to build applications, there are a number of other options available. Your table storage is a critical component of your system. In order to identify a collection of data, you need a set of unique keys and corresponding properties or values. If you need to store large objects, such as files, we have blob storage available. You could also use blob storage to store files like PDFs, images, and other documents as virtual hard drives that can be accessed via the web, with features like caching and metadata that can be stored around those files. Azure queues are available for storing messages that need to be passed between nodes in your application for a short period of time. That in-memory storage can also benefit from the Redis cache and other caching options, which can reduce storage costs and improve performance in some cases. A virtual machine can be used to host a MongoDB document database, as I mentioned when discussing the self-hosted options. You can use Cassandra or Neo4j for a graph database, for example. As a self-hosted service, you have access to a wide range of data storage options, from documents to graphs and columns. This is because Microsoft's Azure Cosmos DB contains everything you might be looking for in a service-based environment such as MongoDB, Cassandra, or Neo4j. This is a one-of-a-kind database in that it allows for the storage of multiple model types. In other words, you can specify whether or not your Azure Cosmos DB database is a graph one when you create it. In addition, the Gremlin API can be used to perform operations on the graph database. Alternatively, you can store the data in a table storage model and access it using the various Azure SDKs. Alternatively, you can set it up as a Cassandra instance and access your datastore using Cassandra's API. Alternatively, you can create a document database and manage documents using either the MongoDB SDK and protocols or the Microsoft API. Clearly, this is a service-based offering that provides an extremely flexible model for storing your data. To take advantage of the fact that Azure Cosmos DB can store data in multiple models, you may want to use it. In other words, multiple masters in different regions can be used, synchronization between nodes is fast, and you can select from 5 different levels of consistency. This kind of system usually requires a trade-off between immediate consistency and slow performance or long-term consistency and faster performance. You can adjust the sliding scale of Azure Cosmos DB to fit your specific needs by selecting from 5 different levels. With Azure Cosmos DB, it's possible to choose the data model and APIs you want to interact with the data store, as well as a globally distributed system that's built for the cloud. Finally, when discussing data storage, I'd like to touch on Azure Data Lakes version 2, which is what I'm referring to here. Using a large-scale data storage like this, we can begin to move toward analytics and analytics tools. File-based or blob-based access is available via the Azure Blob Storage platform. The two models aren't just layered on top of each other, they're distinct from each other. This data lake has been optimized for both file-based and blob API access, so analytics tools can use either to access the files or blobs in it. This means that you get the benefits of blob storage and all that comes with it, including the ability to put data into an archive or cold storage that you don't use as frequently to save money. So, as you can see, each of these options has been specifically designed to meet the demands of cloud-scale application and analytics development. A brief discussion of data processing is warranted, since we now have a plethora of information that needs to be moved around. There will be times when you only need to ingest or process data from your applications, and for those times, we have event hubs. Your messages and data will be put into your data storage using this scalable ingestion model. If you need to move that data, you can do so now, but you can also put it in a data lake or blob storage. And, as previously stated, it is designed to handle large amounts of data from a variety of sources, including telemetry and other systems sending data to your hub. For moving data or performing extract, transform, and load (ETL) processes, we now have Data Factory. SIs and DTS are cloud versions of SQL Server's SIs and DTS, respectively. However, this is more than just a cloud version, it's about loading data from various systems and even different cloud providers, and then processing it in other systems.